Hi, welcome everyone to this tutorial in my channel. Here we are asked to solve for x in this equation. This is an example of an equation involving indices. We have here 5 to the power 2x minus 4 into 5 to the power x is equal to 5. The way forward is to bring all the expressions to one side and let us have 0 on the other side. Alright, I prefer to take this positive 5 from the right hand side to the left hand side. Remember, it is positive. Crossing over, it will become negative 5. And so we have 5 to the 2x minus 4 into 5 to the x minus 5 gives us 0. Now, at this point, we see that 5 to the x is found here. 5 to the 2x carries 5 to the x hiding. Let us bring it out. 5 to the 2x can be written as 5 to the x all to the power 2. Alright? Minus 4 into 5 to the x minus 5 equals 0. Alright? Now, we see clearly that we have 5 to the x squared plus 4 into 5 to the x minus 5 equals to 0. It has the nature of a quadratic. To make it very, very visible, let us replace 5 to the x with another variable, say y. All right, let us rewrite this expression now using y. So we're going to have y squared minus 4y minus 5 is equal to 0. Here the quadratic is now very clear. All right, we all know how to solve quadratic expressions or quadratic equations. We either use the quadratic formula or we can use the factorization formula. Now, let us use the factorization formula here. With the factorization formula, we'll first of all check the coefficient of the leading term. If the coefficient is 1, like in this case, the leading term is y squared, the coefficient is 1, then all we need to do is to get into the factors of the constant term. The constant term here is negative 5. We take two factors of the constant term such that their sum will give us this coefficient, negative 4, and their product will give us negative 5. Now let us start by listing out the factors of negative 5. Factors of negative 5 are plus minus 1, plus minus 5. There are four factors. So we get into this list and we bring out two values whose sum will give us negative 4 and whose product will give us negative 5. Clearly, we have positive 1 and negative 5. The product of 1 and negative 5 gives us negative 5. The sum of 1 and negative 5 gives us negative 4. All right. So next, we are going to replace negative 4 here with the sum of 1 and negative 5. All right. 1 plus negative 5 gives us negative 4. So we have y squared plus 1. 1 plus negative 5 just gives us 1 minus 5 into y minus 5 equals 0. Now let's open this bracket with respect to y. So we have y squared. 1 times y is y. Negative 5 times y is negative 5y minus 5 equals 0. Okay? Now, if we factorize this first two expression and this second expression, coming to this first one, we see y is common. So y is taken out. We're left with y plus 1. Coming to these two expressions here, negative 5 is common. We have y plus 1 equals 0. All right? Pay attention whenever you do such factorization, especially in expressions that involve negative sign. We should be able to check if we have done it correctly. How do we check? Let us open back this bracket to see if we will get back to that expression up there. Negative 5 times y is negative 5y. Negative 5 times positive 1 will give us negative 5. So this factorization process is correct. All right, so we can continue. Now at this level, we will see y plus 1 is also common in both terms. So we factorize out y plus 1. All right, when we remove y plus 1 here, we're left with y. When we remove out y plus 1 here, we're left with negative 5 equals 0. Now, we have the product of two expressions giving us 0. If two things are multiplied together and the result is 0, then either the first one is 0 or the second one is 0. So either y plus 1 is 0, in which case y is negative 1, or y minus 5 is 0, in which case y equals 5. So we have the value negative 1 and 5 as the values of y. Now pay attention, that's not the end of the solution. We were asked to solve for x and not y. All right, so to get the value of x, we will come and put those values of y that we got here in this expression, in this substitution that we made. Okay, now we use that the substitution. We said y was equal to 5 to the power x. Now let's take the first solution here. Now let's leave this one. There's a reason. Let's go to this one first. Y equals 5. If we put y equals 5 there, okay, when we put y equals 5, we're going to have 5 is equal to 5 to the x. Now, 5 is the same as 5 to the power 1. Now, look at it. An index expression equal to another index expression that have the same base. The base is the same, 5, 5. It therefore means that we can equate the power. So that's the value of x when y is 5. So the first solution there is x equals 1. Now, when y is 5, when y is negative 1, we do the same process. So we come and put negative 1 here equals to 5 to the x. All right, so we have negative 1 is equal to 5 to the x. Here, we are caught up with a situation which is very, very impossible. There is no index expression whose value is negative. No index expression, there's no value of x, whether positive or negative or fraction, that will give us a negative answer. So clearly, we see that this solution is not allowed. The solution y equals negative 1 is not allowed. So here we have an impossible situation. So the only solution is x equals 1. So this equation here has only one solution, which is x is equal to 1.